So now a slightly different way to ask a question that you're probably used to seeing. However, sometimes it's not specifically giving us what we need straight off the bat. So let's look at example 4 in this case. We are being asked to find a sub 5, so that is the fifth term, and a sub n, the general term, of the following sequence. And it's geometric. That's the good that they're telling us that. So we're going to look for a few bits of information. So assuming they're giving us 4, that is actually the value of our first term, a sub 1. We have a sub 2 as 12, negative 12, a sub 3 as 36, and a sub 4 is negative 108. So if we were to figure out what the common ratio was, then we could actually find a sub 5 without needing to use a formula. So let's check it out. Let's see what we can figure out. In order for us to get from 4 to 12, we would have to multiply by 3. But if you want to turn it into a negative 12, it's going to have to be a negative 3. Now just double check, and I'm not going to use an X. I think I should use a dot. We'll assume since it's geometric, we are looking at multiplication. In order for us to get from 12 to 36, just verifying that we did the math correct, 12 times 3 is 36. But in order to get a positive 36, we'd have to multiply negative 12 by negative 3. So we can feel pretty confident that we do have our common difference as negative 3. Excuse me, common ratio. Here I am stuck in the arithmetic sequences. So if you want to verify that one more time, just in case, we do need to multiply 36, probably with a calculator, by negative 3 to reach a negative 108. So right away, if you wanted to, all we have to do, if you want to find a sub 5, just multiply negative 108 by negative 3. And we should get our fifth term. And that I would need a calculator, so bear with me. I mean, I guess we could do things in our mind, but we do have the technology. Let's keep it at that. So we do have 324 as a sub 5. So that is part of the directions that we wanted the fifth term. They now also want the general term. So I'm going to take the formula a sub n, that's the general term, as a sub 1 times the common ratio taken to the n minus 1 power. So if we're going to find the general term, what we want to be looking for ourselves is, we know the value of a sub 1, which is 4. And r is negative 3. So we'll take negative 3 to the n minus 1 power. So n, we don't know what it is, n minus 1. And we do have the general term. And that's as far as we'll take it in this course. If you're interested, you can use the concept of exponent laws to help you get rid of this n minus 1. Sometimes this helps in future math courses. So it's just a little sidebar. If you remember the exponent rule, whenever you have a sum, you can split up, or you can split it back up into a product with the same basis. Now, what is n minus 1? If it's a difference, n minus 1 is the same thing as saying n plus a negative 1. So technically, look at this with me. We have 3 to the n minus 1 can be the same thing as 3 to the n plus negative 1. And the little laws of exponents to help us out here, that can be rewritten as 3 to the n times 3 to the negative 1. If you remember some negative exponent laws, we can take 3 to the negative 1, and that's like saying 1 over 3 to the first power. And so an alternative version, if you were interested, we can take our particular problem, kind of show you this negative 3 to the n minus 1. And actually, let me attach this on to make it more consistent with our problem. Technically, we had negative 3's everywhere, right? I'll write that a little bit nicer for you. I do apologize. What do we really get? Negative 3 to the n times 1 over negative 3 to the first power, or really that's kind of a nice one. That would leave us with negative 3 to the n times 1 over negative 3. And so if we wrote that in for ourselves, negative 3 to the n times 1 over negative 3, we would still have the 4 out in front. What you might see is it may look at, let's see if I can highlight this for you. It may look at the non-powers of n, and we can multiply those. They're all factors. So you may see it in this format, negative 4 over 3 times negative 3 to the n. So sometimes that's a nice way if you're trying to make things a little prettier, or if you have to develop this sequence into something else. However, like I said, if you're here, we are pretty happy at this point. So just a little bit of extra knowledge just in case you need it later. Hope this helps. I'll see you in the next example.